Vision is probably the first cognitive capability that was historically added to robots. It has been used for a long time for tasks such as detecting defects on pieces or surfaces as part of a quality control process in factories and the like. But vision is an evolving field and it is getting increasingly more sophisticated. As in any task or any cognitive task related to perception, we need two things. We need sensing so that we can get information about the environment, and we need processing so that we can interpret that information. In the case of vision, sensing is done via a specialized, although very common type of sensors that are cameras. Cameras usually get information about visible light, but there are also cameras for X-rays, thermal cameras, rangefinders, etc. And the most common ones are of the type called CCD, charge coupled devices, that are based on semiconductors. And the cameras incorporate an image function that transforms information about the light into the values of small elements into an bidimensional array. And the tiny elements of that array is what we call pixels. And once we have those values, we apply on them processing. And processing in vision is done via AI, being it a very important subfield of AI called computer vision. Computer vision is done via deep learning using specific types of neural networks. Although there are a lot of architectures and it's an evolving field, a typical computer vision neural networks could say two parts. First part is the most typical one, convolution part, and the second one is the classification part. In the convolutional part of the neural network will have a lot of layers in which each neuron applies what is called a convolution operation on a subset of the previous layer. And that convolution operation is kind of a filter that allows that layer to detect features such as edges, corners, and the like. And the final part of the network is usually a subset of layers of the type called dense layers or fully interconnected layers derived from the multi-layer perceptron architecture, and that are very good in classification tasks. And what can get a robot from these computer vision capabilities? Well, it's a good example thinking, for example, in an autonomous vehicle. An autonomous vehicle moving, for example, in a city and surrounded by a lot of objects. And the first thing the computer vision algorithm gives the vehicle is classification. That is, telling the vehicle what he's looking at. If it is a building, a light, or a moving object, such as another vehicle or a pedestrian. Second, it can get localization. That is, drawing a small rectangle surrounding each object. If the car is moving in a messy landscape with overlapping objects, it also uses detection. That is, telling which object is separating clearly the different objects. And finally, it can get what I call segmentation. That tells, in this case, the car to which object belongs each buried pixel in the image. And that can be used, for example, autonomous vehicles, autonomous mobile robots, drones, and industrial robots. But if you think, for example, in social robots, a social robot could also use facial recognition so that it can know who's the human he's talking to. And we can think also in using cameras and processing just to understand the facial expressions of the human, its gestures, so that the robot can deduce the intention or even the emotions of the human. Well, I guess, as I said, computer vision is a very dynamic field, and I'm sure we can expect great advances in the future years, next years, and even in the next months. Think, for example, in the area of generative AI, maybe a robot drawing creative images, or using multimodality so that the robot can mix and think about images, sounds, and the like. So, as we can expect so many different things, it's better to stay tuned.